Yo friends, join me today as I talk about the absolute wonder and magic of fruit trees and talk about the really cool process of grafting. In short, grafting is a process in which we take a fruit tree and turn it into a Frankenstein monster, where we can grow one variety of apples on a different variety of apple tree. This is the end result here. This bottom half is an apple tree. It's an M111 rootstock. And on top of this M111 rootstock, I have grafted a Gold Rush apple scion wood or stick. So this bottom half, this fruit tree here is on its own roots. It has roots wrapped in a moist paper towel in this bag to keep everything nice and moist, keep it alive. And this would grow into a strong, healthy tree that would produce apples all on its own. The apples would probably be nothing to write home about, nothing special. But this is a rootstock that was bred specifically to have strong, healthy, disease-resistant roots and to pass off those disease-resistant traits to the top half of the tree. It's also bred specifically to be a certain size. It's shorter than like a wild apple tree. So that way I could, in my backyard, reach up and pick apples. I don't have to worry about pulling out a ladder. And to this special rootstock tree, I grafted this Gold Rush apple scion. This is a type of apple tree bred specifically for really delicious apples. So I have strong, healthy roots on the bottom of one variety tree, and I have really delicious apples on the top of the tree. This is a weird trait, I guess, amongst most, maybe all living beings. I know it's true for humans. You can do a heart transplant with this same idea. You have two genetically very similar beings, so two humans with the same blood type, and you put it in the right circumstances, and you can get one human being to accept a brand new heart. And we're simply doing the same thing for fruit trees here. Now the whole idea here is if I, just snipped off an end of this Magnus pear scion wood, snipped off an end, and snipped off a fresh end of this pear rootstock, I could put them together just like this, and they would, if I held them together like this and I kept everything nice and moist, kept everything nice and alive for a long enough period of time, they would graft together. They would start to accept one another. And then this rootstock would start sending its energies up to this top branch here, and this top branch would grow into a full-sized tree. Now this theoretically totally could work and may work, but when we're grafting, what we want to do is increase the surface area of contact point, especially the cambium layer, the thin bit of green right in between the bark and then the center of the wood. So we want to increase that surface area in order to increase the chances of the graft taking. The most common way of doing that is to find two similar diameter pieces of wood. So about a pencil thickness here for the scion wood, and I trimmed this rootstock down until I found they're about the same diameter. And then I make a whip and tongue graft. This here's the whip. I'm taking the scion wood here, I'm taking my knife and I'm kind of holding it backwards. I'm not moving my knife at all, but I'm moving the wood against the knife. So I'm staying nice and safe because the knife isn't moving at all. And I'm cutting the wood at an angle. So it's kind of angled like this. Look at all that surface area. Look at all that surface area compared to if I just kept the ends together, right? So now I have lots of surface area that if I do the same exact thing on the rootstock, I can put these two pieces together and really increase their chances of the graft taking. Look at all of those contact points between these two pieces of wood now. You want to do what you can to kind of make sure everything is as flat as it can and as smooth as it can so they line up real tight together. But of course, the one downside is this isn't a really structurally sturdy. There's a lot of contact point, but even if I'm holding it together like this, it's really easy to knock everything loose. So you've made your whip, and now what you can do to increase the structural sturdiness of this is to make your tongue. Go about a third of the way down with your knife here, and you cut straight down and you cut a tongue into the piece of wood. Now this is where you're gonna get hurt And this is where you're gonna really cut yourself bad if you cut yourself in this process, because these knives are sharp, they need to be sharp. What I've found works really well, instead of like trying to cut or slice, I'm just holding my knife and I'm rocking it gently down. So now I have a whip and I have a tongue. Do the same thing on your rootstock, and then you can combine them together. You can just kind of slide them in together until everything is nice and lined up. I have lots of surface area in contact with one another, and it's a lot more structurally stable. The next step is you want to hold this together for a long period of time. It will probably start to meld and start to graft with one another after a few weeks or months, but that graft will still be pretty weak, pretty easily knocked apart if like a bird lands on the tree or something. You also want to make sure that graft union stays really moist, so everything stays alive. If it dries out, it's dead. So we can use this parafilm tape here. It's kind of this stretchy material, and as you stretch it, it kind of clings to itself. It's a unique thing that's definitely made this whole grafting process a lot easier in the last 50 years. And you can start wrapping it together. So now this graft union is held together by the tape, and the tape is holding in lots of moisture, so everything stays nice and moist, doesn't dry out, doesn't die. I'm gonna put this on a shelf in my basement or a garage for a couple weeks. Once this top half starts to wake up, starts to leaf out, I'll wanna move it outside. But as long as this bottom half, as long as these roots stay moist, so wrapped in like a paper towel and then wrapped with a plastic bag around it, this whole thing, this whole structure should stay alive. And I'm going to keep it on a shelf for a couple weeks and then move it outside and plant it. When I plant it outside, this is still kind of weak. You don't want a bird to land on it and knock everything apart. So I'm either going to put everything in a tree tube to protect from deer, which I have to do on my property anyway, or if you weren't going to do that, you could plant this next to a stake and tie both the top and the bottom to the stake. Make sure the stake is taller than the top, so a bird comes, it lands on the stake. If something else comes and tries to knock things apart, it's tied tightly to the stake, it's not going anywhere. So I've now created a Frankenstein monster, a tree that is two separate beings, two separate genetics that are now growing together as one. And yeah, you could totally take this a couple steps further. As this Magnus pear starts to grow out and starts to become a young tree of its own right, you could cut off a branch from this Magnus pear and graft onto the Magnus pear a different variety of pear tree. And then your pear tree would have roots of one tree and would have Magnus pear and Bartlett pear also growing above ground. That makes pruning way more confusing and difficult, but super doable. You could have a tree growing 3, 4, 5, 10 different varieties of pears. Now it's the same as with making like a heart transplant. You need similar beings. You need two humans, and you also need the same blood type. So you don't want to graft an apple onto a pear or an orange onto a pear. You want to graft pears onto pears. I've heard that you can technically graft an apple onto a pear. It'll last for a few years, make some apples, but it probably won't live a full life. It won't last very long. So keep your pears on your pears and your apples on your apples. Now there's a couple big problems with this method, in my opinion. Number one, if you did your math right, you'll realize that no new pear trees were created in this process. It's not a process of propagation. You're grafting a variety of pear onto an already existing pear tree. So you're not creating pear trees in the world, you're changing the variety of those pear trees. Now the big downside of this is that by relying on this method, if we're using this method for pretty much all of our pears, we're severely reducing the population's diversity. You're not increasing the diversity of pear trees in the world. You're actually really limiting it to only a handful or a couple hundred of pear trees spread out amongst all of our pear and all of our apple orchards. So when a disease or a pest comes in and they really get a hankering for Magnus pears and they get their footholds on that, Or they start to fall in love with Honeycrisp apples, and they found that a Honeycrisp apple is not protective against their attacks. Then that means all Honeycrisp apples across the world are now subject to attacks by this pest or this disease or this pathogen. In the natural process of things, and evolution's natural go about of these things, it solved this problem by lots of diversity. If an apple tree is attacked by a pest and finds itself, defenseless against this pest, chances are that another apple tree in this orchard of many different varieties probably has resistance against this pest. And so the apple trees that aren't resistant die, and the apple trees that are resistant live and pass off their resistant genetics. And it's this long-going war. The pests evolve too, and the diseases evolve too. But you kind of stay on top of everything. You stay ahead of the game with everything. So this process of grafting is really cool. You're holding on to history. You're able to grow the same type of apple trees that George Washington grew. But at the same time, you're also making it really dangerous for your apple trees, because you're not helping them evolve and change, because you're letting the pests and the diseases out-evolve them. So I think it's really important for us to do both. For us to hang on to some of this history, because it's cool, it's exciting, and also you know what you're going to get. If you plant an apple seed in the ground, you're going to get a tree that has traits of both its mother and its father. So you don't really know exactly what you're going to get. You can take some guesses. But if you graft, you know exactly what you're going to get. So there's this big benefit to grafting. But of course, the downside is you're stopping evolution from doing its job. So we need to do both. We need to graft, and I think it's really important we also need to plant apple seeds. Now, if you're a backyard orchardist like myself, you don't really have much space to take a big risk. You don't really have much room to plant a seed and hope that in 5 years it grows into a tree whose fruit you like. I understand that. So I think it's up to some of the big orchardists, I think it's up to some of the people with larger properties to take some of those risks and help spread the genetic diversity of apple trees. And even for a backyard orchardist, it's okay to take some risk. Maybe one of the trees you plant is a tree you planted from seed. Of course, the other downside is trees planted from seed will grow to be full-size apple trees. Whereas these apple trees that I grafted onto this rootstock will grow and stop growing at a certain size. I've heard that their lifespan is typically shortened because of this. They don't like growing on smaller roots. But, some of us just don't have space for a 30-foot tall apple tree in our yard. We do have space for a 10 or 20-foot tall tree. But you think about your favorite apple variety is Honeycrisp. My favorite right now is Gold Rush. These were trees that were planted from a seed. There was only ever one seed in the whole world that was planted in the ground and grew to be a Gold Rush apple tree. And every other Gold Rush apple tree that people love planting around, every other one was having had its scion wood taken from that tree, or another tree with the same scion wood taken from that tree. It all traces back to that same mother tree. So if we don't plant seeds in the ground, we don't get new varieties. Now, some of you may be asking a really interesting question. You're thinking 5 steps ahead and wondering, where did the rootstock come from? If you breed a rootstock and you have name variety of rootstock, but if you plant seeds in the ground, you create brand new trees, how do you have name variety of rootstock where everyone can have an M11 rootstock tree? Really interesting answer. Rootstock is actually propagated, so you're creating brand new plants in the world, via a process called stool layering. So you're taking a tree, you bred a rootstock through seed, taking a tree like this and you're planting it in the ground sideways, piling soil over the roots. And as the tree grows sideways, it sends out its branches straight up towards the sun. And as those branches grow straight up, you pile soil around the branches, And then after the end of the season, those branches will start to send out their own roots. So you have a tree growing sideways, branches growing up, and each one of those branches has its own roots growing out. You can dig the tree up at the end of the year, snip off those branches, and now you have branches, and you can see it here. You can kind of tell, like, this doesn't look like a normal tree with roots. This was a branch that was coming out of a tree, and that branch was sending out its own roots into soil. So you have branches with their own roots. I think the reason people typically don't do this with named varieties of apple trees is that you want them on a certain sized rootstock. If you did this with named variety of apple trees, they would grow to be full-sized Honeycrisp apple trees, which might be awesome for some people, probably not awesome for other people. Additionally, I think these rootstocks were bred not only for size and for disease resistance, but for their ability to send out those roots and to work really well with stool layering. I don't know if that stool layering propagation method would work as well with all varieties of apple trees. So there's your grafting 101. I will say the whip and tongue grafting method is not the only grafting method. There are others, and there are others that work in different circumstances. For example, last year I got a couple rootstock that just were too fat compared to the smaller size scion wood I had. So I had to use a different grafting method because it wouldn't line up right. So there's different grafting methods. You can even take a trunk of a tree, cut down the tree, and around the trunk you can slide in scion wood and graft it to a trunk. So there's a lot of different grafting methods. The idea is pretty much the same. You want to increase surface area between a piece of scion wood and a piece of rootstock and tie it together, keep it firm and steady, and keep the moisture sealed in. And there's a good chance you'll grow a new tree or new variety of fruit onto the same old tree. Happy growing, friends.